So now let's take a look at the motion of a dropped object. So you can take a minute, read through that first paragraph, and when you're done, return back to this video. So please press pause. Now that you're back to this video, in number 10 from our investigation 3 of Unit 2, Lesson 2, it says, suppose an object is released from a hot air balloon 200 meters above the surface of the Earth. Explain why the height in meters of the object above the surface of the Earth after t seconds can be represented by these parametric equations. Well, from your previous work, you understand that an object that is falling falls at a rate of negative 4.9 meters per second squared. Or if it happened to be in feet, it would be a negative 16 feet per second squared. And so the y equation is starting at 200, and an object is falling towards the Earth at a rate of 4.9 meters per second squared. So subtracting from 200, a negative 4.9 t squared gives us the distance above the Earth. And x equaling 1 just takes the equation and moves it off of the x-axis. So if I was to graph this 0, 1, 2, and with a height of 200, my object's going to start up here and it's going to fall towards Earth. And now depending on what we use for our t scale or t interval, that's going to determine the length and how often those dots appear. But now in part B, it says for a specific value of t, such as 1.34, what does the corresponding yt tell you? I've already answered that. Y is going to be the distance above the Earth. Now in part C, it says how many seconds after the drop does the object strike the Earth? Well, using some of the work that you've done in the other classes, you know that when you have an object that is falling to Earth, and this represents the height above the Earth, you can take that equation, set it equal to 0, and solve for t. Now t is going to come out to have two values. The one that we're going to be interested in, I believe, comes out to be about 6.39 seconds. And so it's going to take approximately 7 seconds for the ball to drop. Now the reason why we solve for that is that will help us set up our viewing window. Since it's going to take about 7 seconds for the ball or the balloon or the object to hit the Earth, once it's dropped from the balloon, I'm going to take and have t min equaling 0 up to t max of 7 seconds. And you can use whatever t step you really want. I'm going to use 1/4 of a second. Now for x, let's just go from 0 to 3 because we have the ball being dropped at x being 1 unit. So everything other than x equaling 1 we're not concerned with because it's going to drop down and we will get this vertical line. And your y, well, the maximum height's 200 where the object's being dropped, so let's go a little bit above 200. Let's set that max at 225 and then just a little bit below the x-axis, so we're going to go with a y min of a negative 25. Again, your scale can be whatever, 50, or as I chose, 25. I again used disconnected, so make sure your mode is set for dot, and then when you type your equation in to y equals, make sure you have the 3 little dots to the left of y, or x1 being chosen, so you can get this disconnected graph where each dot represents where the object is at a particular time. Now, I'm not going to go into answering every single one of the remaining questions, but I think I've addressed quite a few of them. Just the last item that needs to be addressed is, notice that the distance between each dot appears to be getting larger and larger. Now, due to the pixel setting, it may not appear that way, but you can see up towards the top how each second that the ball or the object is falling, its distance from the previous 1/4 of a second is not, you're not able to differentiate really how much time is in there because the dots are plotted so closely. Whereas down here you can see that the distance is increasing quite a bit from 1/4 of a second to the next 1/4 of a second. The very last item is on our next slide. It says write a pair of parametric equations that describes the height in feet of an object that is dropped from a point 150 feet above the surface of the earth. Again, this is an arbitrary value. Use 1 because it's just close to the x-axis. And your initial height is 150 feet, but now we're going to use a negative 16 feet per second squared as the rate at which we are dropping towards the earth. Hopefully this video helps you understand how to write a parametric equation for an object that's falling towards the earth. It will help you tremendously on the CYU. So good luck, and if you have questions, we'll address those in class. Thanks.